Welcome to our webinar on Elevate Your Energy Strategy with Microgrid Solution for the Chemical Industry, Part 2. You will receive a valuable information designed especially for electrical engineers, energy managers, facility and grid operators, as well as decision makers in the chemical industry, dealing with sustainability, CO2 reduction, integration of renewable energy resources, and microgrids. My name is Paresh Todkari and I'm happy to be your moderator for this webinar. I'm vertical sales responsible for the vertical chemicals and based out of Erlangen, Germany. And since we receive one question rather often, yes, we will record the webinar and make the recording and the slides available to all participants. If you have already joined one of our last electrification and automation webinars, you already know the Q&A field on the upper right side of this application. Please type in your questions to the presenter and Clemens will answer some of them directly after the presentation at the end of this session. Questions not managed during this live session will be answered via email. And just in case you are in the full screen mode, please escape to see the Q&A field for questions and the chat box for short comments. In this webinar series, we focus on the energy transition to renewable resources. Therefore, Microgrid Solutions supports you in integrating renewable energy resources, reducing CO2 emissions while in parallel lowering energy cost, optimizing power system and driving sustainable growth. In the first part of our Microgrid webinar series for the chemical industry, we focused on industry requirements and the introduction of Microgrid solution. You will find a link to it in the presentation handout. Today, in part 2, we will learn more about the required functional packages depending on your application. Now let's have a look at the agenda. First, we will give you an introduction to our functional packages philosophy. Then you will get a detailed explanation of the available functional packages. In the third part, you will see some real-life examples and applications in the industry. Last but not least, we will answer the most frequently asked questions. Our today's speaker is Clemens Wegehaupt. Clemens is a practical pragmatist and passionate improviser. He has been working for over 10 years in the field of microgrid, renewable energy and energy efficiency. He moved from the conservative business of a general planning for larger power plants to innovation in the field of microgrids and renewables. According to Einstein principle, if you can't explain something simply, you haven't understood it. He tries to inspire and sensitize people for this topic. Clemens, we are curious to learn more about microgrid solutions in the industry. The stage is yours.
Yeah, thank you, colleague, for this nice introduction and welcome to my part. So again, microgrid control. This time the functional packages we have bundled out of this large set of single functions, overall and asset-specific functions, and the content of these functional packages. So it's, so to say, the market hot sellers. So it's bundling the most common challenges in the market, in the industrial markets, also other markets. And we see, for example, we need a possibility to smooth the load profile with tie line control and peak shaving, for example. Another functional package is about demand charge reduction, so lowering power costs and enabling reserves in your grid connection. And we all know demand charges can be pretty expensive, especially for industrial customers. Then we have one functional package covering the dynamic load management for e-car charging. So bundling functions and also hardware in a package to allow and avoid this grid bottlenecks and to allow the integration of this e-car charging equipment into your existing grids. Then island operation, that's where we come from with microgrid control. So island operation for pure island systems. So without grid connection, ensuring a stable supply, ensuring voltage and frequency is stable, as well as the integration of renewables. And last but not least, so here regulation coming from the European Union. In Germany, we call this EZA control. So Erzeugungsanlagenregler, the ground laying or underlaying standard is a VDE 4110, 20 and 30 for medium, high and highest voltage. And here we talk all about, like grid codes, DSO requirements and conformity to these rules. The packages, these functional packages, the philosophy behind it. In the first part of this webinar, we saw different functions of microgrid control. So it's a large set of functions available in our application. And we analyzed the market, we analyzed the years of experience we have in industrials or with industrials and with microgrid control, and we took out different functions of this huge set, bundled it in different functional packages to tackle the challenges of different customer types. So customer types means, we have different industrial customers like manufacturing industry, different types, and therefore we have bundled functional packages. Means in each of these packages is different functions or a different combination of functions tackling different challenges or different drivers. So different functional packages available. The good thing is we saw this example in the first webinar about a reference lamine. So a journey starting with an idea, ending up in like a business case, but not stopping there, as the world is also not stopping and we have new technologies, new possibilities, and we need probably to extend our existing set of functions. For example, to being able to integrate new technologies. One example is e-car charging. No one knows what's coming next, and our functional packages are able to be extended with different functions. So it's not a fixed set. So you can also move with these functional packages. We already had a look at the set of currently available functional packages. So this is from time to time also extended, as also the market is moving. And as next topic, we will have a closer look at each of these functional packages. I will explain a little bit, probably roughly, what's the thinking behind the functional package, what can be solved or what can be tackled with this functional package, what's the driver behind it, and some practical examples. So let's begin in having a look at the first functional package, tie-line control and peak shaving. So tie-line control and peak shaving is always required or the case if, for example, your grid connection is limited somehow. For example, you have an existing medium voltage transformer which were made for your application, for your process, for supplying of your system. And I once was responsible for calculating and engineering, designing, sizing of these transformers. And I know there might be power reserve for 10 to 20%, but that's it. So if you want to extend your system, you have two possibilities: placing a new transformer to have more power available, or controlling your system in an intelligent way to, for example, use reserves. One example. Then we can use this scenario or this package also to maximize the own usage of generation or the impact of renewables. In fine-tuning the schedules for tie-line control or the set points, you can, for example, shift your renewables or the generation of your renewables, like PV during noon, in this time, for example. You can take or you can consider set points from an external source, like network operators or DSOs, to control your system. We once have had a real nice opportunity and project which was covering this requirement, as there the grid operator was searching for the possibility to, for example, control different microgrids within his grid in a coordinated way. So he sent set points to the single microgrids, that the single microgrids is helping to keep the grid stable. And in some cases, we see the requirement because, for example, backfeed or infeed into the grid is not allowed. So you cannot use your PV generation to feed it into the DSO's grid because it's prevented because of contractual things or regulations. Even there, this functional package can help. How does it work? So up here beside me, we see again one example of a load profile and the green line, one example of this tie line control function. So with our microgrid controller, we integrate in the system a secondary controller. We interface the different assets to the microgrid controller as we see it in this simple example. And we set, for example, limits, power limits like here. We set a power limit and the microgrid controller is then actively and in real time controlling the assets available to fulfill or ensure that this wished load profile is followed. How do we do that? For example, we use gensets, generation sources, to be switched on, if we want to get more energy in the grid. Or we also can use energy storages, if we must take energy out of the grid. Plus, we have also a integrated load management system, which is connected to switchable loads if existing. So loads can only be switched if allowed. So mostly it's non-critical loads. We can automatically switch off for this change in the load profile. Your benefit in having this functional package implemented in your system. So it's possible with your DSO to define individual grid tariffs. This tariff structure and this the possibility is getting more and more bigger. It's getting more flexible with your DSOs as this energy world, the energy landscape is changing. So DSOs mostly are really interested if you ask them, for example, how my load profile shall look like that you, DSO, benefit from, so that I help to keep the grid stable, for example. Then we have, for Germany, individual network charges available, so different possibilities that you avoid network charges. Then electrically or physically, we can ensure that you can use reserves in your grid, in your transformer, by analyzing your load profile and then, for example, shifting peaks from high peak times to, for example, times without loading of the transformer. This means we have increased independency with this solution, which is future-proof. Again, our solution is completely vendor independent, and we can also integrate new technologies in a later point of time. The next use case is demand charge reduction. So it's slightly similar to this peak shaving scenario, but with different Googles on. So in peak shaving scenario, we are purely considering in the control the measured power flow, for example, on a transformer, on a point of interconnection to the grid. Here in the demand charge reduction scenario, we have different Googles on. We are not using the power measurement, we are using the energy measurement, which is also used to bill your energy consumption. And usually, or in most cases, it's considering 15 minutes cycles. So your DSO is measuring 15 minutes of your power consumption, is calculating the energy amount of it, and with this Googles on, we are ensuring, for example, you see this on this example, cut off or being able to, first of all, predict by extrapolation. So microgrid controller is extrapolating the real-time load profile to the end of this 15 minutes accounting cycle, and by that is able to detect those peaks, like in this example. It's I always describe it as low energy but power intensive peaks, we can detect it before it happens, and we can take measures to cut it off. And this means really a really high potential for you, our customers, in lowering this power costs. And especially in industrial customers, the power costs can be really one, or if not the biggest part in the energy bill. So microgrid controller, same way in implementation, is connected to the available assets, like generation assets, but also loads. And the microgrid controller is able to control, like in peak shaving, to control these different loads. So we are measuring, we are extrapolating the load profile to this 15 minutes accounting periods. And if there is a peak occurring, microgrid controller is taking measures, for example, starting gensets. We have some customers with old CHPs or gensets available. Some cases was emergency gensets. They are now using it to really lower the energy bill. In some cases, really dramatically. And with this switching on of own gensets, this peak is cut off. Or vice versa, with our load management system, so we can define up to 30 loads in the microgrid controller with, for example, different times, for example, a maximum switch off time or a minimum switch on time, and so on. And the microgrid controller is then, if possible, switching off the different loads if, for example, such a peak is occurring. So you see this in this example. This low energy, high power peaks are cut off. In best case, then your load profile is smoother than before. And with energy or with this power costs in Germany of around 100 euro per kilowatt, a huge potential is given with this functional package. Means your energy costs or power costs are reduced again. In some cases, you have the possibility to discuss about flexible grid tariffs. You can use your existing infrastructure, even, for example, with more or new load integrated in the system. You can avoid grid expansion, which is really or can be really expensive. And again, you have more independence like before with our future-proof solution. Yeah, next use case or next functional package is, for example, the DLM, so Dynamic Load Management for e-car charging. Dynamic load management for e-car charging, in these days we see really a booming market for e-cars and a booming market for charging infrastructure, and we see very often bottlenecks in electrical systems. I have explained, I was responsible some years back in the design and engineering of those medium voltage transformers. In most cases you have reserves, power reserves of 10 or 20% of its rated power, but then nothing anymore. And this situation can occur. So there we see again an example of a load profile with in green, if you have to, for example, because of standards, regulations, rules, or other things, you have to integrate charging infrastructure into your electrical system. For industrial customer, can mean integration for your employees' cars on a parking lot, or for example, for your fleet, for your trucks. You have to integrate e-car charging infrastructure. This can mean, we see it in this example, that you will violate or overshoot the limits, the electrical, physical limits of, for example, your grid, your transformer. How to tackle this? Again, two possibilities: placing a new transformer, putting more copper in the ground, having more copper available to transmit the required power, or you control this e-car charging infrastructure in an intelligent way. With DLM, we have a lot of strategies available to coordinate the different charging procedures. I would like to point out to again another webinar about DLM. It's also available. There's also a nice video in YouTube available about e-car charging control. And in this case, we are integrating a DLM controller, so the same platform as a microgrid controller, but with a different application in your system. We are measuring the electrical power of the different chargers. So it's a simple example. And we are coordinating the different charging procedures in a way that the overall system is staying below this physically or electrical limit of your transformer, of your grid. So we are avoiding this grid bottleneck, and we are enabling that it's possible that you are integrating your required e-car charging infrastructure into your grid. So, operation within the boundaries of your existing grid is possible. So the reduction of demand charges is also one benefit, as you avoid these peaks in charging. And also the grid extension is avoided in best case. Plus, we can also combine this use case, this functional package, with some other functions. And for example, you can make this limit also dynamic in combining this DLM controller with a microgrid controller, for example. The microgrid controller will then calculate the limit dynamic for this DLM solution. And it's a perfect fit. It allows really highest efficiency in combining this use cases, combining these functional packages and these controllers. Yeah, we have one scenario, one functional package, which we were coming from, so to say. So microgrid control, this microgrid controllers was once designed, so like years back in time, for island systems. And an island system, one thing has to be ensured, that voltage and frequency is stable. This is the first and the prior one focus. But most of these island systems currently are supplied by fossil fuels, like gensets, which are fired with diesel or gas. So you have relatively high emissions in these systems. So sometimes inefficient generation, if you combine, for example, PV or renewables with this combustion engines, you always have to ensure that the engines or the gensets are loaded above a certain limit. In case of combustion engines, around 30%. If not, it's really inefficient in operation. With microgrid control, we can ensure that all of the systems are operated with the highest efficiency. So we are connecting the microgrid controller to the different assets. There is a slight fault in this slide. This is correct. The microgrid controller is then conducting, remember from session 1, like in an orchestra, the different energy sources. And with microgrid control, we have the chance to reduce the operational costs, we're reducing the emissions, and we maximize the resiliency of the system with a fully automated control with our microgrid controller. Last functional package is starting or coming from a use case in Germany. In Europe, it's more complex regulations regarding the rules being allowed to connect to a grid. So this was coming from a standard like this VDE 4110, 20 and 30. I already explained that. 10 is for medium voltage, 20 for high voltage, 30 for highest voltage. So it depends which type of customer you are or your system is. And with these requirements, all of the customers which are in these standards or hit by these standards has to integrate or ensure that this overall system is having a certain behavior towards the grid. So you have to ensure, even if, for example, you have renewables on site and there is a peak in your generation, that your system is helping more or less the grid being stable. So you always have to have a certain dynamic behavior. So we have to measure the load flow to the grid and then to act in a certain way to help the grid being stable. So we have here one example of a profile of a reactive power and voltage profile we have to ensure in case if we would like to connect to the grid. The microgrid controller is certified after all three standards, so 4110, 20 and 30, and so we can help our customers in medium voltage, high voltage and highest voltage grid being able to connect to the grid. Means with this controller, with this EZA controller, microgrid controller, you will be compliant to these different standards. You can then consider like the technical conditions of connecting to the grid. The fully automated control of, for example, active and reactive power, and you can also take like signals and commands from outside, from an external source. So, for example, from DSO, and microgrid controller is trying to fulfill this commands. All signals are stored for 18 months in an archive within the controller. And again, we have the possibilities, like in all of our functional packages, to equip this solution with a CCAM Web HMI or an SEC HMI. So all of our functional packages, as well as our platform, this microgrid control application, is following the latest standards. This is one thing very important for Siemens, being able to really deliver solutions for the whole world. And this is one very important topic, especially the certification of regarding this VDE standards for Germany, in Germany, but also the other European countries was the last month one very important topic. And with microgrid control, you can be sure that we fulfill all of the required standards in case of control and energy automation. Closing this session with having a look at some references again. Again, we have our reference like Lemene, this commercial campus in Finland. It was an idea of our customers years back. The idea was, you see on this picture, you have this large industrial site or district available. The customer must supply, for example, also this shopping mall you see in this picture, this large thing with thermal power as well as electrical power. The initial idea was being able to supply the grid as a pure island, so also in blackout situations to supply the grid with energy. And with these functional packages and the microgrid controller, it was possible to fulfill this requirement and more. We extended this reference or this system then over the time with more and more functions and use cases. So you see, it's not a static thing, these functional packages. You can extend the system with different other functions if required. So in this Lemene environment, with having multiple CHP units, so this combined heat and power generation, with multiple PV systems, with multiple energy storage systems, as well as fuel cells metered in the system. Our use cases was to reduce energy costs, to increase resiliency, also in case of grid blackouts, but also to participate on different energy markets. It was possible to enable this customer not only covering this use cases he had in mind, but also to really create a business case for the customer. He now earns money with this system, with this hybrid generation system, with this microgrid. Very complex projects like Lemene, or complex in terms of combination of assets. We have also simpler use cases like Upper Blinkwater. It's a community in South Africa. It's residential people living there, and there the main focus was stable supply, a stable energy supply of these households, of these residentials. By second priority, reducing the fuel consumption. In the past, it was supplied by conventional gensets, so diesel-fired gensets. Now the customer was thinking to extend this fossil fuel-powered systems with renewables, getting rid of the fuel consumption or lowering the fuel consumption. With microgrid control, it's possible. We set it up there, a hybrid system consisting of PV, the gensets plus battery. Use case again was resiliency. It's the first focus, but also lowering like the fuel consumption. And for the customer, this was like a living lab. So here we continuously are trying to improve how the system is looking like. For example, if it makes sense, for example, to integrate wind turbines, it's in stage 2, but it's a perfect example that the microgrid controller can cover really huge complex systems as well as really small systems like this one. With these functional packages and with our pre-bundled hardware. Please have a look at the first session of this webinar. Microgrid control can cover really modular, simple and flexible, really a huge, diverse set of challenges and use cases. Again, why microgrid control, why CCAM, why Siemens? So the key takeaways is of these functional packages, but also the platform. With using microgrid control in your system as a conductor in your system, we have enhanced resiliency. So this conductor can really shift energy streams following the real-time requirements. So you gain or you get more resilience. Then economic benefits. With the integration of renewables, we can, for example, lower fuel consumption, or we can lower the consumption of the outside grid. So we can lower your energy bill, but also your CO2 footprint. We have industry-specific solutions. So I spoke about this market hot sellers. So this is the result of years of our experience. So I started in Siemens 15 years ago in this field of smart grid and microgrid. And during this time, we really experienced some really great projects, and we learned out of this project. So this is tailored packages to really fit into this industrial or industry-specific solutions. Then stable and reliable supply, as one of the most important things for industrials, especially for industrials, we have to ensure that your process is kept stable, and microgrid controller can do though and can help with. Why CCAM? We learned that this world we live in is highly dynamic. We have new technologies, we have new communication protocols, and we need future-proof systems. So our system as a future-proof system, fully vendor independent. We have proven reliability regarding our platform, our products, as they are used in thousands of energy automation and microgrid projects all around the world. We have robust security. If you have a look at the first part of this webinar with our mechanisms regarding cybersecurity, we are equipped with the tools helping you to get really the fitting cybersecurity concept for your requirements. And why Siemens? Siemens, I'm really proud to work for such a company, giving you the possibility to really get a tailor-fitted solution on your use case within streamlined processes. We can help you as a partner, also as a partner known as one of the most, let's say, sustainable companies on this planet. And last but not least, Siemens as a long-term partner. We can ensure that we can partner for years, and in these long-term partnerships, we can go together to the best fitting, to the tailor-fitted solution, helping you in case of sustainability, stable energy supply, lowering your costs, and helping you in implementing your idea. Yeah, thank you very much. And after this presentation and this statement of our founder, Werner von Siemens, it's one of our favorite or my favorite statements is ideas alone has a little value and innovation importance lies in its practical implementation. So we saw this examples like Lemonade. We have a lot more of these examples available. And I think these ideas are in your heads. Let help you to implement these ideas in really a practical implementation. And now I think having a look at this huge set of terms on the screen, so like load, asset, energy management, renewable integration, DSO approval, compliance with different regulations. If you see one term in these topics, please contact us. Please scan this QR code. It leads to a set of nice functions, nice informations. And after this, stage is yours for your questions and for our answers. Thank you very much. And so for this time, it was really a pleasure and an honor to guide you through the functional packages, and stage is yours. Thank you for your questions. I'm looking forward to it. Thank you. Great. Stage is yours. But okay. Yes. If there is no question, I hope that all questions already answered. And I'm looking forward probably to your message about opportunities, your challenges. Would be really great to see some. To get some messages, and if you have a question or an idea or a challenge regarding microgrid control, please contact us. Thank you very much.
Dear auditorium, thanks a lot for your questions, and thank you to Clemens for all your answers. Still open questions in the Q&A queue will be answered via email. And if questions come to your mind later, please contact our specialist. I'm sure they will get back to you soon. In the upper right-hand corner, you find Microgrids for Chemical Industry brochure and the webinar presentation for your download. As the download area is not visible in full screen mode, you may have to press Escape. Access to the recording is automatically available to all participants directly after the session with the same link you got for the live webinar. Thank you very much for your active participation. It was a pleasure for me to guide you through this session on microgrids for the chemical industry. We learned about our 5 functional packages of microgrid control, which focuses on smoothing the load profile, demand charge reduction and energy control, e-car load management, is Iceland operation, and conformity with our grid operator. I'm looking forward to meeting you in one of our next webinars. Till that time, stay safe and sound. Take care. Goodbye.